Good afternoon. Today we're going to be doing the first day of Unit 2. Unit 2 for pre-calculus is linear functions. And the first day we're going to concentrate on absolute value calculations and properties, and then basic Cartesian calculations. And of course, Cartesian means in an XY plane. So let's start with absolute value. Oh, by the way, we will also be doing a little extra grapher calculation at the end, so you might want to get your grapher handy before moving on. All right, absolute value calculations. Here we go. Number one, on a number line, the absolute value is going to give you the distance between coordinates. So your distance between coordinates is the absolute value of 0.1 minus 0.2 or vice versa. It goes in either order. So for example, if we draw a number line and we mark -5 as one coordinate, -1 as another, we can call -5.1, -1.2, and to find the distance between them, we're going to do the absolute value of -5 minus a -1. Now notice that there's one negative from the formula and there's one from the -1. So you will have double negatives. A negative times a negative is a positive. -5 plus 1 is a -4, which is 4. This formula is most useful when the numbers are weird or strange or fractional or something that you can't just count on your fingers. So it's good to know the formula in case things get strange. Okay, number 2, properties. There's only a couple properties we're going to be focusing in on in this lesson. The first property is if you have two quantities, A times B, multiplied within an absolute value, you can actually split it into absolute value of A times absolute value of B, and vice versa. So this one goes both ways. Division is the same way. If you have a fraction A over B or A divided by B in an absolute value, you can split it into absolute value A over absolute value B, and vice versa. So those are the two properties that you're going to see the most often. They're pretty straightforward. Okay, so one of the questions you're going to be getting on your homework is they're going to say to write, and they're going to give you an absolute value, 3 minus pi, without the bars, without the absolute value bars. So you have to remember that an absolute value takes out the sign. If it's positive or negative, everything comes out of it positive. So to write it without the bars means you have to split it into both possibilities, a positive and a negative. So you'll have a positive 3 minus pi and a negative 3 minus pi. Notice that the bars go away when you split it to evaluate. So distribute the positive, nothing changes. 3 minus pi is one of our answers. And then here you're going to distribute the negative, so you get -3 plus pi as your other quantity. Now, if they want you to actually give a numerical value without the pi symbol, you would need to substitute pi, 3.14 ... but you'd want to do it on your calculator so that you have all 39 decimal places. All right, so one of the first applications of this, being able to split an absolute value, is solving. We're going to solve the absolute value of x plus 2 less than or equal to 6. So the way you do that is you split into positive and negative. So positive x plus 2. And for right now, we're looking for critical points. And because it's equal to 6, we're going to make this equal to 6 because we want to know the boundaries. And then after we find the boundaries, we can find the inequality. So on the right side, a negative quantity, x plus 2, equals 6. And I'm going to skip a couple steps here. We end up with x equals 4 as one boundary. and we end up with x equals -8. So this first part is strictly to find the boundaries. Okay, so then after you found the boundaries, we need to figure out where this graph is. So draw yourself a number line. And it doesn't have to be super exact, but we have a -8 here and a 4. Obviously, -8 is smaller than 4. Now, because this is less than or equal to, these get filled in dots because they can be equal to -8 and or equal to 4. So what we're going to do is we're going to test to see where our graph is. And you always test in the original. So test in the original. And we have to test these boundaries. So pick a number less than -8. Let's try -10. If I substitute that into the original, I get the absolute value of -10 plus 2. Is that less than or equal to 6? And as it turns out, you end up with an 8, which is definitely not less than a 6. So no, that number did not work. So no, we do not have any solutions to this below -8. Now we pick a number in the middle. I'm going to pick 0. So absolute value of 0 plus 2, is that less than or equal to 6? We end up with a 2, which is definitely less than or equal to 6. Yes, so we have solutions between -8 and 4. The last interval we need to test on is 4 and higher. So I'm going to pick a 5. You could pick 6, 7, or 8. Anything bigger than 4 will work for the test. So absolute value 5 plus 2, is that less than or equal to 6? You end up with a 7, which is definitely not less than 6. So the solution area that we have is between the -8 and the 4. And we're going to write the answer as a set. So x is an element of, now we're going to learn a little notation here. If the endpoint is included, we're going to use interval notation. You use a bracket. If it is not included, you use a parentheses. This is included, so you get a bracket for -8 and a bracket for 4. So -8 up to 4, inclusive. So brackets are for what we call closed endpoints. And just in case you've not seen interval notation before, if it was something like x greater than 3, not equal to 3, it would be x is an element of, you'd have a parentheses for the 3, and it would go up to positive infinity. Because it's greater than and not equal to, it would get a parentheses. Okay, so let's go on. That's our absolute value calculations. We're going to move on to Cartesian point calculations. So Roman numeral 2, Cartesian point formulas. Hopefully these are all review for you. All right, formula number 1 is distance formula. And your formula is a big radical, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And the subscripts on the points are for point 1, which is x sub 1, y sub 1, and point 2, which is x sub 2, y sub 2. Now, just like the number line, you do not have to worry about the order of the points, as long as they go into the formula where they belong. Okay, so let's do an example. We've got a point -3, -5, and another point -2, 0. And we're going to find the distance between the points. All right, so I'm just going to designate these in order. X sub 1, y sub 1, x sub 2, y sub 2. All right, let's feed those into the formula. So distance equals gigantic square root x sub 2 minus x sub 1. So -2 minus a -3, quantity squared. Of course, you have one negative from the formula and one from the 3. That's why there's two negatives in there. y sub 2 minus y sub 1, 0 minus a negative 5, quantity squared. And now it's a game of simplifying. You know that a negative times a negative is a positive in both these cases. So negative 2 plus 3 is a 1. 0 plus 5 is a 5. Now do the exponents. 1 squared is 1. 5 squared is 25. 25 plus 1 is 26, which is 2 times 13, so nothing simplifies. That would be your distance. So that is your distance formula. Okay, number 2, midpoint formula. So midpoint formula, the actual equation is x sub 1 plus x sub 2 divided by 2. That gives you your x coordinate. Y sub 1 plus y sub 2 divided by 2. Now, I don't actually think of it that way. I think of it as the average of the x's and the average of the y's gives you the midpoint. Again, x1, y1, they're just delineations for points. So x1, y1 is your point 1. Point 2 is x sub 2, y sub 2. Now, I'm not going to go over this one because it's a pretty easy formula. I guess I could go over a quick example. Let's just use the same 2 points. Negative 3, negative 5, negative 2 comma 0. We're going to designate our points, x1, y1, x2, y2. Put them into the formula. So x1 plus x2, so negative 3 plus a negative 2 divided by 2. Now the y's, negative 5 plus 0 divided by 2. Notice I'm not putting an equal sign. This is a coordinate point. It's not in and of itself a giant calculation. It's just a point. So a positive times a negative is a negative. So negative 3 minus 2 is negative 5. So we have negative 5 halves. And negative 5 plus 0 is negative 5. So negative 5 halves. That would be your midpoint. Pretty straightforward. Number 3, Pythagorean Theorem. Pythagorean Theorem. All right, Pythagorean Theorem is a calculation that can be done in a coordinate axis. I'm going to draw a right triangle here. If you have to find lengths for a right triangle that's in your coordinate axis, the verticals and the horizontals are pretty easy. You can just use your absolute value formula and find the difference in the y's. Same thing here. You can use your absolute value formula and find the difference in the x's. So those two sides are pretty easy to find lengthwise in a coordinate plane. What's difficult is to find the length of this one. This one you can't use the absolute value formula. You have to have Pythagorean theorem. So in Pythagorean theorem, A is the length of one of the legs, and this is a leg. B is the length of another leg. C is the length of the hypotenuse, which simply means the side opposite the 90 degrees. So your Pythagorean theorem is a squared plus b squared equals c squared. So once you've found length A and length B, you substitute them into the formula and solve for C. So for example, let's say that you found length A was 4, length B was 5, and you needed to find C. You would substitute those lengths into the formula. So 4 squared plus 5 squared equals C squared. Simplify. 4 squared is 16, 5 squared is 25. So exponents first, then add or subtract. That's 41 equals c squared, and then extract square roots. Now, normally we would get a plus and minus, but because we're talking distance, you can't have a negative distance. So you're really only going to end up with a positive C value. The negative one is extraneous. And 41 happens to be a prime number, so that would be your answer. Square root of 41. If you don't know what units you're dealing with, miles or inches, we usually just say units. That tells you it's a length, not like an area, which is like units squared or something like that. Okay, so those are our 3 Cartesian point formulas. Okay, Roman numeral 4. I'm just going to give you some area formulas in case you need them. We have the area of a rectangle, which is area equals length times width. Sometimes you'll see it area equals base times height. It just depends on what you're used to seeing. Of course, the area of a square is easy because the sides are the same. So area equals side times side, or area equals side squared. And then, of course, we have a triangle. Area of a triangle is 1/2 base times height. And you got to be very careful that the base is perpendicular to the height. This formula only works with a right triangle. So right triangles only. We're going to learn some other ways to find triangle area as we go along in pre-calculus, but up until now, you would only have this. So if you had a triangle that was not a right triangle, you'd have to cut it into pieces in order to figure out what the base and the height was. And that might involve midpoint formula or distance formula. All right, Roman numeral 5. We're going to do some graphing calculator stuff. We are going to do what we call a best fit line. Now, before now, when you've done a best fit line, it's typically been where you have a scatter plot, and then you would take your ruler and try to find the best line to represent the data, which actually the human eyeball is pretty accurate, but naturally a graphing calculator would be a little more accurate. So for the purpose of this, we're going to use number 29 from your book, which I will show you. We're going to draw a scatter plot and we're going to do a best fit line. So we're using number 29. This is U.S. motor vehicle production. It says the total number of motor vehicles in millions is Y, produced by the United States each year from 2009 through 2015 is given in the table. There's our table. So really important is this Y is in millions. You always want to write that down because if you're asked to calculate something later, you're going to need to remember that. All right, we are going to make a scatter plot of the data, and then we're going to do a best fit line. So let's pull out your grapher. Okay, so first thing you need to do is input the data. Let me turn off a light. That might help a little bit. We're going to input the data. So you want to go to Stat, this button, Stat, and then Edit. Now, I've got some garbage in my first column, which is L sub 1. So push the up arrow till you highlight L sub 1, push clear and down arrow, and it will take everything out. Now, I've gone ahead and entered the data for the Y here. I need to enter the data for the X's. A simple return will work. So 2009, enter. 2010, enter. 2011, enter. 2012, 2013, 2014, and then 2015. I tend to enter the data fast, but then I go back and double check it, because if even one of them is off, it's going to screw up your scatter plot. All right, so we've entered the data in Stat. Now, you might have something in your Y equals button. So go to Y equals. If you have anything in there, clear it out, because that will mess up your graph. So that will turn off your linear menu. We now need to turn on your scatter plot menu. So up here in Y, there's a blue one that says stat plot. So second stat plot. Now notice the stat plots are off. That's your default. You generally want them off, but we need to turn one on. So we're going to push enter on number 1. We're going to push on. Now type, you have to go by kind of picture. The first one has dots. That's your scatter plot. So push enter. Now here's where you tell it where to get the X and the Y. We put the X's in list 1, the Y's in list 2. If you have to change that, you'll notice that on the numbers of your calculator, you have L1, L2, L3, 4, 5, 6, 7, 8, 9. You have to use the blue shift. So if that's not set to what it needs to be, then you need to use the blue shift and take care of it. All right, let's set our window. Now right now my window is set to 10s, which obviously will not work. So X's, my lowest X is 2009. So you want to usually go 1 unit below what you have. So I'm going to go 2008. X maximum is 215, so I'm going to go 2016. And if I just go by ones, it's going to be a solid black line of tick marks, which won't do us much good. 2009, 10, but these are actually going by ones, so that might actually work. I'll leave it ones. We'll see what it looks like. Okay, Y minimum, 5.59, so I'm probably going to make a Y minimum 3. My maximum is 12.10, so I'm going to make it like 14. And these are definitely going by small increments. You could go by 0.5s, but I think that will be all right. And then go ahead and hit trace, and you should get a scatter plot. So on your homework, when you're doing grapher work, your proof of work is a simple graph, and then I'm just going to put the points generally where I see them. What's really important is the window. You always put the window on. So 2008 to 2016 for the X's, and we did 3 to 14 for the Y's. You also might count your points and make sure they're all there. 1, 2, 3, 4. I should have 7 dots. 1, 2, 3, 4, 5, 6, 7. I have them all. Your grapher will leave dots off if you pick a wrong window, so you do want to make sure that you've got them all in there. Okay, so now we want to do a best fit line. So you're going to go again into your stat menu. So push the button that says stat. Edit is where we put the points, so right arrow to calculation. There's 2 linear regressions, which is what they call fitting a line. There's one in the form ax plus b and one in the form a plus bx. We generally want to use ax plus b because we want our line to be in the form y equals mx plus b. So linear regression, you push enter, and it's going to ask, where do you want me to get my x's? Where do you want me to get my y's? And when that's all set up, push enter. So what it's going to do is it's going to give you the generic equation at the top, which in this case is y equals ax plus b. Why they don't use m, I don't know. And then they're going to tell you what a and b are. So a in this case is 1 point, and you want to give it a few decimal places, 0.079x, plus I'm going to round the b. Oh, it's not plus, it's minus 2160.564. So that is the equation of a best fit line, much more accurate than you could do on your own. Now, if we want to go ahead and make sure that this equation fits our data, we're going to graph it over the top of it. So go into your y equals menu, and you're going to input your line. Y equals 1.079x minus 2160.564, and then hit trace. And it's really cool. You get to see your line kind of going through the middle of the data. This line's going through the data. We're trying to fit a linear curve to data that isn't linear, so it's not that great. but it is there. So our linear curve ended up being about like that. That would be a graph of the best fit line. Okay, that concludes our note taking for today. You know how to input data, how to do a scatter plot, how to do a best fit line. I hope it was helpful, and I will see you later.